This is a video that is very close to my heart because this is a story that is essentially my story. How I went from being a non-engineer and not having touched maths for a lot of years to getting a 99.99 percentile at the QA. So we have to understand where did I start from. So the first bit that I'm talking about is I had not touched math for 6 years. So my graduation was 5.5, 6 years. And in that entire duration, I had not touched math at all because I come from an MBBS background wherein there are no maths subjects whatsoever. But I had a decent grasp on concepts and had a decent academic profile. So I had an 8, 8, 6 kind of an academic profile, which can be considered as slightly above average or average in nature. Now, what exactly did I do in my initial phase? And I will be explaining this entire bit with the help of an entire concept. So stay tuned throughout the video to learn the concept in the way that I learned it when I was an aspirant. So there is a lot of content also as a part of this video. Now, in the initial phase, what happened with me was I went to a lot of these online prep forums that were there, and they were also there back then. I went to these forums. I saw a lot of people solving a lot of complicated questions using terminologies like Euler's formula, Fermat's theorem, Chinese remainder theorem, and whatnot. I essentially got overwhelmed. I was not expecting this to appear at the CAT. So I was taken aback by the competency of the people who were also preparing for the test. And then I decided that I needed to go back to the basics. It would not happen overnight that I would simply go and muscle my way through all these questions that were there. I had to find out what exactly were the concepts that were tested at the CAT 1, and second, how could I get better at the concepts that were there. Now, I figured out there were 3 stages of learning, and that is relevant in your case as well. The first stage is essentially the learn phase, wherein you will try to learn as many concepts as you can. The second thing is you will need to recall all the concepts that you would have learned. So just learning things is not enough. You have to be able to recall them at the right point in time. And the third stage of learning is essentially application of the formulas that you would have learned, because when it comes to the test, you will not be asked all the questions in a linear manner. Your first question could be from concept A, your second question could be from concept B, your third question could be from concept C, and so on and so forth. So you have to be very comfortable applying your learning in a randomized manner as well. Now, how do you go about the learning phase? And this is where I'm going to teach you one entire topic. So the first thing we are talking about is in terms of having a concept repository. You should know what all concepts you have studied. So you should be very well organized in terms of your notes that you would have prepared. And the second bit that you need to understand is what are the interesting questions that you would have encountered in your entire preparatory journey. So you should also make notes of the questions that you would have found interesting. Now, in terms of concept repository, what I will do is I will teach you one entire concept of triangles quickly. So in terms of triangles, what I did was I had a mental map of what triangles would look like. And because I had that, it was very easy for me to replicate it on this PPT as well. So how do you start with triangles? So the first thing is you have to understand the basic properties of the triangles. Now, just saying that there are basic properties of triangles will not really cut the deal. You have to understand what all are the basic properties. So I have memorized that there are 4 basic properties that I need to know in terms of a triangle. The first thing is sum of any 2 sides has to be greater than the third side. The second thing is the side opposite the largest angle is going to be the longest side, and conversely, the side opposite the smallest angle is going to be the shortest side. Also, we know that sum of angles of a triangle is 180 degrees, and consequently, we know that in any triangle, the exterior angle is equal to the sum of the 2 interior angles that are not adjacent to it. So these 4 are the basic properties that we have. Now going on to the next step of triangles, what is the next concept that I wanted to learn? Classification of triangles on the basis of their sides. So if all 3 sides are equal, we know that it is an equilateral triangle. If 2 sides are equal, then we call it an isosceles triangle. If no 2 sides are equal, we call it a scalene triangle. Now there's one thing that I had made a mental note of, that every equilateral triangle is also an isosceles triangle, but every isosceles triangle need not be an equilateral triangle. So that was the depth to which I had learnt this concept. And I'm sure that if you just go through this video at a slower pace, you pause at the right intervals and have your own notes in this meticulous manner, you will also be able to remember things the way I did. The second thing I wrote here was classifying triangles on the basis of the nature of their angles. So we have acute angle triangles, right angle triangles, and obtuse angled triangles. But the learning does not stop here, because I know there is something that is present in terms of a right angle triangle that is very important, and that is a square plus b square being equal to c square. Now a square plus b square, if it is equal to c square, then we will call it a right angled triangle. If a square plus b square is greater than c square, we will call it an acute angled triangle. And if a square plus b square less than c square, it will be an obtuse angled triangle. On the basis of that, we can also figure out Pythagoras theorem and the converse of the Pythagoras theorem that exists here. And the last bit we have to understand in terms of angles and triangles is 30, 60, 90 triangles and 45, 45, 90 triangles. So they are also subsequently derived from the Pythagoras theorem. So in any triangle with angles 30, 60, 90, the side opposite to 30 degrees is half the length of the hypotenuse, and the side opposite to 60 degrees is root 3 by 2 times the length of the hypotenuse. And in any 45, 45, 90 triangle, the side opposite to 45 degrees will be 1 by root 2 times that of the hypotenuse. So this covers the entire classification in terms of sides and angles. The next bit in terms of triangles is similarity and congruence. Very straightforward concepts. If two triangles have the angles that are exactly the same, but the sides are in the ratio of each other, then you will call them similar. And if sides, angles, everything is equal, then we are going to call them congruent triangles. Now again, my learning does not end here. You have to understand how to figure out similar triangles and congruent triangles. And a lot of time I used to make this mistake that ABC is similar to PQR. And how do I figure out ABC and PQR are similar and ABC and QRP are not similar? That would be a problem. So to counter that, what I had kept in mind was I always used to look at the vertices with the same angles. So if angle A is 30 degrees, then angle Q, if that is 30 degrees, then A will correspond to Q. If B is 70 degrees and if R is 70 degrees, then B will correspond to R, and so on and so forth. So that is how I had made a mental map of identifying similar triangles and congruent triangles. In terms of one concept that exists here in terms of similar triangles is the perpendicular to the hypotenuse in a right angled triangle. And then there are three rules that exist here. And if you know these rules, you will be able to understand what I'm trying to say here. So if ABC is a right angled triangle with the right angle at B, you will know that AB square is going to be AD into AC, BC square is going to be CD into AC, and the middle one, BD square, is going to be equal to AD into CD. So all these three forms you will be able to identify. You will be able to appreciate the fact that the three triangles that are formed, if you drop a perpendicular to the hypotenuse from the right angle, are all going to be similar to each other. So this is one very important concept that very few people are comfortable with. And if you make a note of it, if you understand it and remember it well, you will be able to understand this concept completely as well. In terms of the next concept that we are talking about in triangles, construction within a triangle, there are four things that I am sure all of you are aware of. One, you have to join all the altitudes that are there, and all the altitudes will meet at one point. It can be inside the triangle, on the triangle, or outside the triangle, and this point is called the orthocenter. Then there are three medians. Median is essentially the line joining the vertex to the midpoint of the opposite side, and that is called a median. All three medians will meet inside the triangle, and the point that will be so formed is called the centroid. Now centroid also comes with its one small rule, wherein the triangles that are formed, the six triangles that are formed, if you join the three medians or if you construct the three medians, will all be equal in terms of area, and the area will be 1/6 of the area of the larger triangle. The third thing is the point of intersection of the perpendicular bisectors. Again, it can be inside the triangle, on the triangle, or outside the triangle. Now it's your homework to figure out when is it inside, when is it on the triangle, when is it outside. And the point of intersection of these three perpendicular bisectors of the three sides of a triangle is called the circumcenter. The radius is the circumradius, and you can construct a nice circle that will pass through all the three vertices. The fourth construction that we have here is angle bisectors, wherein you will have three angle bisectors. They will meet at a point. That point will be equidistant from each of the sides of this triangle. It will always be inside the triangle. And if you construct a circle with this perpendicular distance to each side of this triangle, you are going to get a nice circle that will touch all three sides of this triangle. and that is called an in circle. The radius is the in radius, and the point of intersection of the three angle bisectors is the in center. Now, in terms of the equilateral triangle that we have here, all these points will essentially be at the same point. So all these points of intersection will be the same point inside the triangle. In terms of the right angled triangle, we have one or two things that you will need to remember. One, the circumradius of any right angle triangle is going to be half of the hypotenuse, and we also need to know that the orthocenter in any right angle triangle, which is the point of intersection of the altitudes to the sides, is going to be on the vertex that is the right angle as well. Now, once you have figured these things out, we are going to the area of the triangle and the perimeter of a particular triangle. So area of a triangle, there are 5 formulas: half into base into height, root of s into s minus a into s minus b into s minus c, where s is the semi-perimeter of the triangle, half ab sine c, ABC by 4r, where capital R is the circumradius, and r into s, where r or small r is the in radius and s is the semi-perimeter. So these 5 formulas you have to remember very well, because in any question that involves the area of a triangle, you will have to apply one of these formulas. The next thing I'm talking about is the perimeter and semi-perimeter, very important concepts. The perimeter is nothing but the sum of the lengths of all sides of a triangle. Semi-perimeter is half of that. We know that the longest side is always going to be less than ABC by 2 or A plus B plus C by 2. It is going to be at most equal to A plus B plus C by 3. So ये याद रखना है. The next bit is p square by 48. So we have to figure out how many triangles with integral side lengths are possible for a particular perimeter. Then there are 3 formulas or 2 formulas that exist: p square by 48, the integral value of that, and p plus 3 square by 48, the integral value of that. So again, this is something that you can remember. I am not explaining the entire concept. I am just telling you the notes that you should have with you. And then coming to the last part of triangles, special properties is what we should know. What all are the special properties? The basic proportionality theorem. So if there are 2 points on 2 sides of a triangle that divide the 2 sides in the same ratio, then the line joining these 2 points is going to be parallel to the base. In other words, if you are looking at the midpoint theorem is a corollary of this, which will say that the line joining the midpoints of 2 sides of a triangle is parallel to the third side and is half the length of it. And then in terms of the Apollonius theorem, whenever you have a median, AB square plus AC square is 2AD square plus 2BD square. That is something that you can sort of memorize as well. The angle bisector theorem is again very important, especially in terms of the CAT. So in this particular case, there is an internal angle bisector theorem and there is an external angle bisector theorem. There is one thing I always get confused as to which one upon which one will be there, क्योंकि अगर बाहर मिलते हैं, then you have to extend the angle bisector and the side, and then that creates confusion. तो उसके लिए मैंने एक बहुत simple rule अपने लिए बना के रखा था, which was the notation remains the same irrespective of whether we are looking at the internal angle bisector or external angle bisector. Meaning, if AD is the angle bisector and ABC is the triangle, then internal angle bisector theorem से क्या पता चलता है? AB by AC is BD by CD. That's it. External angle bisector में भी exactly same notation होगा. AB by AC is going to be BD by CD. So that is how it works, and if you can remember it like that, great. So all these are mental notes that I had made for myself. Now, in terms of question repository, whenever you find an interesting question, you can take a screenshot of it and put it in a PPT, or you can put it in a WhatsApp group that you have with yourself, and you can write some notes that are pertinent to that particular question. So in this case, let's say this is a question from one of the daily drills that we had recently conducted. In that question, what I figured out was integers and numbers are 2 different things. So कहीं पे भी अगर numbers आता है तो I should not assume them as integers and mark something as the answer. तो वो मुझे नहीं करना है. So that is one thing that I told myself, and because of that, this question is special to me. Let's say I'm looking at another question जहाँ पे 3 sides of a rectangular park have a total length of 400 feet. ऐसा कुछ question था मेरे पास. यहाँ पे एक बहुत important concept है मेरे पास, AM greater than or equal to GM. तो कोई भी पॉजिटिव नंबर्स के लिए AM is always going to be greater than or equal to the geometric mean, and AM equal to GM कब होगा? When all the terms are equal to each other. So these 2 are my takeaways from this particular question. Throughout the season, whenever you come across a question that you think is interesting, इसका ऐसे एक नोट बना के कहीं पे रख देना, so that you can keep on referring to it again and again. So this will take care of your learn part, और ये अगर करते रहोगे you will definitely do well in terms of learning the concepts. The second stage as I mentioned was improving your recall. अब याद तो कर लिया लेकिन बार बार कैसे उसे वापस लेके आएंगे, from your brain back से लेके front तक कैसे उसे लेके आएंगे. So for that you have to go through these two repositories once every 3 days. So let's say Monday evening before you go to sleep, you go through this entire repository of theorems and concepts that you would have learned. Tuesday रात को you go through all the questions that you found interesting in this entire season. जैसे जैसे you progress, you can maybe hide some slides or you can play a game around and you can just see what it means to randomize these things and figure out कि ये question मेरे लिए special क्यों था. That is what is going to help you improve your recall. You also have to predict the next concept that is going to come on screen. So ये जितना ज़्यादा आप करोगे, it's like memorizing a song, it's like memorizing a movie sequence, it's like memorizing a dialogue, memorizing anything that you would have memorized in your life. And once you do it a lot of times, you will be able to recall very, very well. And after a point in time, you will not even have to look at the PPT to recall whatever you have written there. So in terms of triangles, I have gone through that bit so many times that even if you ask me what were the special properties, I can recite you those special properties in order: basic proportionality theorem, midpoint theorem, Apollonius, angle bisector, and so on. So all those things will come naturally to you if you keep on doing the process again and again and again. So you have to rinse and repeat this entire bit that we just went through. And if you do it for all the concepts that are there, I think you are going to do a fantastic job when it comes to the quant section. The third bit, most important part, now you have learned the concept. अब उसको apply करना है during the test under the presence of a timer. How do you do that? You have to go for a mixed bag of questions, and that is precisely why in terms of daily drill, the ones that we have been doing initially are the ones that are segregated on the basis of area. So I have all questions from geometry in one daily drill. I don't say we will do only questions based on triangles, we'll do only questions that are based on quadratic equations, and so on and so forth. We will do a mixed bag of questions, and it is going to get even more comprehensive as we go forward, because now after daily drill 50 we are going to have questions that are mixed bag in nature and across areas, because you will have to reach that level wherein you are solving questions from multiple areas simultaneously, and वो करके ही application better होगा. For that, what you have to do is you have to solve sectional tests, because sectional tests के अंदर you will have questions from all across the section. You have to go for past CAT papers and past CAT questions in the form of a sectional, so that you are able to apply your learning well. The third thing is daily drills. As I mentioned, initially we were going for area-wise daily drills, but as we progress, we are going to move on to quant section-based daily drills. And the last bit is mocks. Of course, mocks will be the ones that will be the closest to the CAT in terms of level of difficulty, split between the various areas, and so on. So make sure that you take as many mocks as you can. Now, what all things are there that you should do? I can think of 4 things here. The first thing, very important thing, is you have to love the subject. Now, if you have reached till this point in time in this video, I am sure that you have a genuine interest in improving yourself and also learning the subject. So keep that up and make sure that you keep the love for the subject intact. Don't start hating the subject or trying to find out shortcuts that you will get out somewhere and you will leave a particular set of questions and so on. Don't do all those things. They are not going to help you at all. The second thing is learn the basics extremely well. There is no other way of getting better at quant than to learn the basics very well. You have to have rock solid concepts. There should be nothing that is left to chance. If someone comes and tells you that the circumcenter is always inside the triangle, you should be able to tell them, no, the circumcenter need not be inside the triangle. It can be on the triangle in case of a right angle triangle. It will be outside the triangle in case of an obtuse angled triangle. If you have such clarity in life in terms of conceptual knowledge, I think you are going to do a great job when it comes to learning more concepts as well. The third thing, you have to understand, you have to never give up in terms of your preparation. You have to keep on fighting till the last day. I have seen cases wherein people were hopelessly bad at quant and they knew it. I am not exaggerating when I am saying they were hopeless at quant. They were so scared to even calculate averages of 2 numbers. It was that bad. And then these people were persistent. I have to give it to these people that they stuck around. They meant business throughout the entire journey. They never gave up. And at the end of the day, they got a respectable score. I'm not saying they got into IIM Ahmedabad and IIM Bangalore, but these people ended up getting into top colleges like say MICA, SIBM, NMIMS. So I know all these cases personally, at a personal level, I have guided these people sometimes to the extent of being frustrated that how can you not understand such an easy concept. But I have seen people doing wonderfully well and getting into these colleges. I have also seen people getting into ISB for that matter and doing well at the GMAT as well. So make sure that you don't give up. You have a long list of people who can inspire you, and definitely you can do it as well. And the last bit, you have to get a 90 plus percentile in at least one mock. Once you have tasted blood, I am sure you will be able to do an amazing job at the section, and you will end up doing amazingly well at the actual test too. Don't get scared by all these talks of the level of difficulty being high or you not being able to solve a lot of questions and so on. It's perfectly okay. The level of difficulty is going to be manageable. So don't get worried about things that don't exist. So if you have liked this video and you wish to implement these strategies into your preparation, make sure that you leave a like. If there's something you need more elaboration on, do put it in the comment section below. If you like the channel, do subscribe to the channel and share it with all your friends so that we have a larger community with whom we can interact on a regular basis.